Good morning, students. In my last lecture, I have told you about the basics of geometry, which will be used in solving the questions. This chapter 8, class 10th mathematics and trigonometry. So, directly I will be doing example and exercise. So, what's then my first exercise question? I have taught you sine, cos, tan, secant, cosecant thing. So, let me solve this question. The example number 1, that is tan A is 4 by 3. Find the other trigonometric ratio of angle A. So this is my example. First, it is given that tan A is nothing but 4 by 3. So it is, this is tan A, which is the angle is A. So this, I'm supposing this is my angle A. I'm taking this to be angle B, and this to be angle C, and this is 90 degree. And this A is given to be 4 by 3. Tan is going to be 4 by 3. So let the common ratio of sides be k. I'm supposing this, my side is k. Now from this triangle you can see that tan of A is nothing but perpendicular by base. So for here, perpendicular is this BC, by base is AB. Now this ratio is given to be 4 by 3. This is not that BC equal to 4 and AB equal to 3, but the ratio is this. So if I am taking the common ratio between of sides BK, then I can write BC as 4K and AB as 3K. From here, as the ratio BC by AB will be 4K by 3K, which is nothing but 4 by 3 only. So this BC will become my 4K and this AB will become my 3K. My 3K. What is saying that calculate, find the other trigonometric ratio of angle A. Now from this you can calculate that by using, see this is 90 degree and you don't know AC, so using Pythagoras theorem, that is AC square equal to AB square plus BC square. Now what is AB square? 3K square plus 4K square equal to this is 9K square plus 16K square, nothing but 25K square. And this is my AC square, which implies that AC nothing but under root 25K square. This is plus minus, but since this negative is not possible because the side is always positive, AC equal to 5K. AC equal to 5K. 5K. This is my 5. So from here, what is it? See, tan is given to me with 2. Tan is given, so you can easily calculate cot theta, or in place of theta it is given that it is cot of A is nothing but 1 by tan A, which is nothing but this is 4 by 3, so 1 divided by 4 by 3. Let me write it here. So 1 divided by 4 by 3, nothing but 3 by 4, which implies that tan cot A is 3 by 4. Even you can write cot A to be base by perpendicular, was base is 3K by 4K, nothing but 3 by 4. Now other ratio is sine of A is equal to, my triangle was like this, which this is my A, this is B, this is C, this is 90 degree, and this I have calculated as to 4K, and this is my 3K, and this is comes out to be 5K. So sine A is BC by AC, that is perpendicular by hypotenuse. So from This perpend BC is nothing but 4k, and this is 5k, so this is lighter to sine this 4a by 5. Now cos A is nothing but base by hypotenuse, and base is here is AB by AC, which is nothing but 3k by 5k equal to nothing but 3 by 5. The sinus is cos A. Now tan A you have calculated, cot A, tan A was good, cot A you have calculated, and then there becomes cosecant A. Cosecant A is, you know that cosecant A is hypotenuse by perpendicular, so hypotenuse is 5k by this 4k, which is 5 by 4. From here you can see that this is inverse of sine A, so it's cosecant A. So secant A, another one, the secant A is nothing but hypotenuse by base, hypotenuse is 5k by 3k, nothing but 5 by 3, and from here you can see that this is inverse of this. This is inverse of this. So I have calculated all the trigonometric ratios possible here. Now example number 2. If angle B and angle Q are acute angles such that sine B equal to sine Q, then prove that B equal to Q. See, sine B and sine Q. So here figure is not given. You must draw the figure and always take 90 degree, and this is to be B, and another triangle I am taking, this is nothing but this. I am drawing a bigger, this is Q, and this is M A C B P R Q, this and this. Now what is given in the question is that sine B equal to sine Q. Sine B equal to sine Q, it is given. This is given. You have to prove that angle B equal to angle Q. To prove that this angle equal to angle. Now sine B, what is sine B from here? Yes, sine B is nothing but perpendicular by hypotenuse. Perpendicular is AC by hypotenuse is AB. Now sine Q is nothing but this is also perpendicular by hypotenuse. So perpendicular is PR, by hypotenuse is PQ. Now since these two are equal, which implies that AC by AB equal to PR by RQ. AC by AB is PR by RQ. Now this is your equation. Now if now you know that what is A. You know that by applying Pythagoras theorem, AC square plus BC square equal to AB square, and applying Pythagoras theorem here, you know that this is PR square plus RQ square equal to PQ square. Pythagoras theorem, applying Pythagoras theorem. Now if I divide this equation by AB, dividing this by AB, that is from this, and then from here dividing, and this is divide the whole equation I'm dividing by PQ, then you can see that this is nothing but AC by AB and square, dividing this by square, AB square, AB whole square plus BC by is also AB whole square, nothing but AB by AB whole square, A by A square. Now from here you know that AC by AB is PR by Q, and the P I can replace this by PR by RQ whole square plus this is my 1, and this is BC by AB whole square. And from here if I write this equation here, that is PR by RQ PR by PQ whole square plus RQ by PQ whole square equals to 1, that is PQ by PQ square is 1. Now from here you can see that this 1 and this one is same. PR by Q and PR by Q whole square is same, which implies that value of this and this is equal. Yes sir, value of this is equal, which implies that RQ by PQ equals BC by A. Okay. So from here only you can see that AC by AB. So here you can write it that is AC by PR equal to AB by RQ, and if you write this as, if I take it as numerator, this will become AB by PQ equal to BC by RQ. AB by PQ, AB by PQ, sorry, is AB by PQ by RQ, not on this, I have to represent this, AC by AB, AC by AB is equal to PR by RQ, no, not RQ, this is not RQ, this is PR by PQ, sorry, this is P, because this is also PQ, sorry, this is PQ. Now from here, what to see that this is AC by PQ equal to AB by PQ, and here AB by PQ equal to this, so which implies that BC equal to BC by RQ only. Now you can see that if all the three sides of two triangles are proportional, then triangle ACB ACB is similar to triangle PRQ PRQ, and since they are similar, which implies angle B equal to angle Q, hence proved. They also done the same thing. They have taken sine B by sine Q. This is no, this is say this K, then this is calculated by using this, so this is also remains, so the equation also remains this K only. So using this equality theorem, that this, if this is similar, then for this angle B is equal to angle Q. Now third example number 3, consider a triangle ACB I am considering triangle right angle at C, in which AB is 29, BC is 21, and angle ABC equal to theta. Determine the values of cosecant square plus sine square theta, cosecant square minus sine square theta. So example 3, it is given that this is ACB, AC and B is 90 degree at C, ACB 29 21, this is 29 and this is 21, and angle is theta, angle B is theta. Now they are saying that you need to find the value of cos square theta plus sin square theta. Second, cos square theta minus sin square theta. Now from the formula I have told in advance, this is not given till now, but in advance in cos square theta plus sin square theta value will be 1. But here, since this is your exercise, and before that they have not shown that sin square theta plus cos square theta is 1, so you need to prove that this is true. So if you now, since this side is given, so using Pythagoras theorem, this AC square plus CB square is equal to AB square, and which implies AC square is not given, this BC square 21 square equal to 29 square equal to 29 square minus 21 square, this is AC square, this 29 square minus A square minus B square. Never expand this. This is 29 plus 21 and this is 29 minus 21. There are 2 3 to the 4 50 into this minus this is into 0, this is 8. It has a 400. It's much easy. Now AC is equal to 400, which implies that AC is equal to under root 400. This is plus negative is neglected, or side cannot be negative. So this is 20. So this is 20. Now what is cos theta? Now from this diagram you can say cos theta is base by hypotenuse. Is nothing but this base is 21 by hypotenuse 29. So cos theta is 29 and cos square theta is 21 square plus 29 square. Now what is next is sine square theta. So sorry, sine theta is given to be from diagram that sine theta is 20, this is perpendicular by hypotenuse, which is nothing but 20 by 29. So this is sine square theta will be 20 square plus 29 square. 20 square plus 29 square. Now if you add the two, that is cos square theta plus sine square theta, nothing but 21 square plus 20 square, 29 square, 20, 29, 21, 29. Okay. And if you expand, this is 21, 21, 441 plus this is 400 by this is 841. 29, 29 square if you calculate, this is 841. So if you add this is also 841 by 841, this ultimately comes out to be 1. And you also know that this cos square theta plus sin square theta is equal to 1. So here although it will get proved as it. Now what is next is cos square theta minus sin square theta. Now if you want to calculate this, so value of cos square theta is 21 square by 29 square and minus 20 square by 29 square. And if you do this, this is 20. If you take the LCM, this is 29 square only. Then this is 20 plus 21 plus 20 is 21 minus 20. It's nothing but this is 41 into 1 by 29 square. This is nothing but 41 by 481. This is your answer. This cos square theta minus sin square theta will be 41 by 841. Now if you see that this is, you know that this is 41 by 841 and this is 1, which is proved. So next question is, in a right angle triangle, right angle at B, you have to always see that what is the right angle. My right angle is B, so this is round D. And if tan A equal to 1, and verify that 2 sin A into cos A is equal to 1. Okay, then 2 sin A is equal to 1. So here this is also much simple, no need to do anything. This is example. So this is given that it is right angle at, it is given this is right angle at B. So this is I am taking this A, not here, I am taking this A. So this is A and it is given that tan A equal to 1. You can from it given it, you know that tan 45 degrees is 1. So and you can even guess it that this is yes A tan 45 A must be 45 and angle C also be 45. No, it's not. So next what do you do? This is calculate the value of tan A. So what is tan A from this diagram? Tan A is perpendicular by base, and for this perpendicular is BC. This is BC by AB. There is nothing given to be this as 1, which implies that AB equal to BC. Let's suppose I am taking to be this as constant K. I am taking this to be constant K. So both the side, that is this will be K also, and this side will also be K. Now there is only one theorem I can apply, Pythagoras theorem. Right triangle always apply Pythagoras theorem. AB square plus BC square equal to AC square. That is So AB square is nothing but this is K square, this is also K square equal to AC square, which implies that AC square, if you, this is 2K square, which implies that AC equal to under root 2K square, which is nothing, this is plus minus, but you know that negative is neglected, this will be only plus, so this is under root 2K. This K is outside this, and this is in unit. I have taken this to be K unit. This will be my K unit, under root 2K unit. So the value of this AC is under root 2K. Now what is you have to find is the 2 sine A into cos A. 2 sine A into cos A. You have to put that this is 1 to 1. Now from here, the diagram considers the sine A nothing but perpendicular by hypotenuse. So this perpendicular is this is BC, and value of BC is K. And this is BC, and this is by AC, which is nothing but this BC is, what is this BC? This is K, and this is under root 2K, which is nothing but under root 2. So like sine A is under root 2, and same you calculate cos A. This is nothing but this will also be, this is now be AB by AC, but AB is equal to AC, so this is K by under root 2K, 1 by root 2. And if you know from this, even from this, is that this, for this tan A equal to 1, A equal to 45 degree, and you know that sine 45 degrees 1 by root 2, and even cos 45 degrees also root 2. So from here also you can calculate that this is 1 by root 2. So now this what you have to prove is 2 sine into cos A. So you can write it that this is 2 into sine A. What is sine A is 1 by root 2. What is cos A? And cos A is also 1 by root 2. So this 1 by root 2, 1 by root 2 becomes 2. So this is 2 into 1 by 2, nothing but equal to 1. Now this is my LHS, and this is my RHS, and those things both are equal, hence my the question which has been given is proved. Hence proved. As simple as that. They've also done the same thing, but you can even take it to be the angle. Now in the triangle OPQ, right angle at P, it's given that right angle, it is a P is the right angle. OP is equal to 7 centimeter. OP minus PQ is 1 centimeter. Determine the value of sine Q and cos Q. Simple. Nothing special in this question also. Nothing special. Let me change my background to some good backgrounds. So this will make me feel like I am doing it on my board. So just kidding. Feeling will be same, but it looks good. In right angle at P, and this is QO, OPQ. So what is going to, this is right at P, and OP 7 centimeter. OP is going to be 7 centimeters, and OQ minus PQ equal to 1. OQ minus PQ equal to 1 centimeter. 1 centimeter. So what you need to find is sine Q cos Q. Sine Q cos Q. Remember, since OQ will always be greater than OP, this hypotenuse is greater than any side. This is proved from here also. That is OQ minus PQ is 1 centimeter, which is the OQ is greater than. So since this is given, you need to go from this only. You take OQ from here. OQ is equal to, if you take this to be right on right side, this is 1 plus PQ. 1 plus, this is 1 plus PQ. Now what you need to apply, which theorem? Sir, only there is one theorem I can apply. This is Pythagoras theorem. Yes, Pythagoras theorem. Pythagoras theorem, which is OQ square equal to PQ square, Q square, which implies that what is OQ? OQ is given to be 1 plus PQ equal to OP square. Now if you see from this, is 1 plus PQ square plus 2PQ equal to PQ square plus OP square. Now if you see that this is PQ square and PQ square get cancelled, Yes sir, PQ squared is cancelled, and from this given is in question, it is given that OP is 7. So this is 1 plus 2PQ equal to 7 square equal to 49, which implies 2PQ to 49 minus 1 is 48, which implies PQ is equal to 48 by 2, nothing but 0 to 4 the 8, this is 24. PQ is 24, which implies my PQ, oh sorry, sorry, this is my PQ, and PQ is 24 centimeters. Now this is 24 centimeter, and from here this is OQ equal to 1 plus PQ, which implies that OQ equal to 1 plus 24, which is nothing but 25 centimeters. This will be my 25 centimeters. These all are values you have to find. So this sine Q from here, this is sine Q is perpendicular by hypotenuse. From this sine Q, this is my perpendicular. So this is OP by OQ. It's nothing but OP is going to be 7 by 25. And from sine cos Q is base by hypotenuse. For this base is 24. This is 24 by 25. This is OQP by OQ is 24 by 25 is 7.25. So 7 by 25, 24 by 25. Simple. Now, and coming to exercise 8.1. Exercise 8.1. Finally, I am doing the exercise 8.1. Exercise 8.1, question number 1. What it says that in a triangle ABC, right angle at B. Clearly, it is given that ABC, this is in a triangle ABC, right angle at B. ABC, my innocent triangle. I am taking AB to be 24. This AB is 24, and centimeter, and BC is 7 centimeters. Determine sin A cos A sin C cos C. Sin A cos A sin C cos C. Simple. Now only one theorem I can apply, Pythagoras theorem, which says that AC square equal to AB square plus BC square. Now from here is AC square is nothing but AB is 24 square plus 7 square. There's 576 plus 49, nothing but 625. This is the AC square, which implies that AC nothing but plus minus under root 625. Negative is neglected, but this is 25 centimeters. AC equal to 25 centimeters. So you can write this that this is 25 centimeters. Now, what is sine A? Sine A equal to, from this, if you look from here to here, sine A is perpendicular by hypotenuse. Perpendicular is BC by AC, 7 by 25. And cos A is equal to base by hypotenuse. This is base is AB by AC, which is nothing but 24 by 25. Now if you look at the sine C, from the sine C, this is my perpendicular. So if I take sine C is perpendicular by hypotenuse. Perpendicular here AB by AC, nothing but 24 by 25. And if you calculate cos C will be nothing but base will be BC by AC, is nothing but 7 by 25. This is my answer. Now in figure 8.13, find tan P. This figure was given to you. This is saying that tan P minus cot R. Tan P minus cot R. (90°) 1213 P R Q. I think this is Q. This is Q. 12 centimeters. Calculate what? 10 P minus cot R. 10 P minus cot r. Now from here, for this p, if I'm taking this to, this is tan p, nothing but perpendicular by base. For here perpendicular will be QR by PQ. Now you don't know what is QR. From Pythagoras theorem, you know that PQ square plus QR square equal to PR square. Pythagoras theorem, which implies PQ square 12 square plus QR square. QR you don't know, this is 13 square. So QR square equal to nothing. You never need to open this because this is minus. So this is 13 plus 12. This is 13 minus 12. 30 plus 12, 25 into 1, which is nothing but 25 only. So QR square is 25, which implies that QR equal to plus minus 20 under root 25 negative neglected, which implies that QR equal to under root 25 is 5. Is 5 centimeters. 5 centimeters. So this is my 5 centimeters. So if you calculate this is QR is 5 by PQ is 12. This is my 5 by 12. Now what is cot R? Now if you see from this angle, see from this angle R, this cot R is nothing but base by perpendicular. So base here will be 5 by, base will be here. I'm not I'm writing that. So base will be my QR by PQ. It's nothing but 5 by 12. And if you subtract this 2, this will become 5 by 12 minus 5 by 12 will give to 0. So this will be 0. And if you want to do it in short, since this is not given, this theorem is not given to you earlier, so this will be after exercise. So I'll directly, if you want for this, it can be given 1 mark question also. So this is cot R, you can write is at tan 90 minus R. Now what is tan 90 minus? This angle P plus Q equal to 90 degree. P plus R equal to 90 degree. 90 degree, which implies that P equal to 90 minus R. Which implies a P is, if you use a substitute value of P, which is nothing but 10P minus, this will be also 10P, nothing but C. Directly you can get that this is C. So next is sine. If sine A is 3 by 4, calculate cos A and tan A. Calculate cos A and tan A. So if sine A is 3 by 4, so it is given that if sine A equal to 3 by 4, so you need to draw a diagram where your A is and suppose this is B 90 degree, this is C, and this is, since this is 3 by 4, so if you assume this of sine A is as per figure, sine A is nothing but from this into C here, that is BC perpendicular by hypotenuse is AC, which is nothing but 3 by 4. And if you take common ratio as K, so it implies that so it is BC will be 3K and AC will be, this is yes, this is 3 by 4, 3 by 5, 3 by 4, yes, 4K. So this is my 4K, this will be my 3K. Now applying Pythagoras theorem. Applying the Pythagoras theorem implies that AB square plus BC square equal to AC square, which implies AB, you don't know this AB square, I will leave it here, this is 3K square equal to AC square is 4K square, which implies that this is AB square plus 9K square equal to 16K square. So AB square equal to 16K square minus 9K square. This is nothing but 7K square. It's AB square, which implies that AB is nothing but under root 7K square is equal to under root 7 into K. So this value will be under root 7K unit. So now what you need to find is that you need to find cos A and tan A. From here, what is cos A? Cos A is base by hypotenuse. Base is under root 7K by hypotenuse is 4K, which is nothing but under root 7 by 4. What is tan A? Tan A is nothing but perpendicular by a base, which is nothing but 3k by under root 7 under root 7k, which is nothing but 3 by root 7. It's the answer. Which is the answer. There are other methods also, that is cos square a. You know that 1 is 1 minus sine square a. Now from this you can calculate cos a equal to under root 1 minus sine square a, and from here this is given that this is 1 minus 3 square by 4 square, which is nothing but under root 7 by. You can directly calculate here that cos a is 7 by 4. And for tan a, you know that this is nothing but sine a by cos a. If you divide this two, that is sine a by cos a, you get that is nothing but 3 by root 7. Yes. But this is not given here till up till knowledge of here. I am making you solve this answer. So already 36 minutes over. Now given 15 cot a equal to 8, find sin a and secant a. So in next question number 4, given that 15 cot a equal to 8, what you to find is sin a and cos a equal to what? So sin and secant a. So secant a equal to what? So if you draw the diagram from here, you can see that this is cot a equal to 8 by 15. This is a b c. For this angle a, this ratio is 8 by 15. So if I take common ratio as 8, so cot a is base by, so this will be 8k and this will be 15k. And what will AC? AC will be AC square. Will apply Pythagoras theorem. This is 15k square plus 8k square whole square is nothing but 15 square 225k square plus 8 is 64k square. This will become 9 6 7 8 289k square, which is AC square, which implies that AC equal to 17k. So this is, after calculation I get it that this is by 17k. From here, this is, if you calculate value sin a from here, this is perpendicular, this is perpendicular by hypotenuse, nothing but 15 by 17. And if you calculate secant a will be this is hypotenuse by base, which is nothing but hypotenuse 17k by 8k, nothing but 17 by 8. That's. Now next, if A and B are acute angles such that cos A equal to cos B, then show that angle A equal to angle B. Angle A equal to angle B. What do you mean by acute angle? Acute angle is angle less than 90 degrees. Acute angle. Obtuse angle greater than 90 degrees. Obtuse angle. So these are two angles. So it is given that these two angles are acute angles. Acute angles. If we are given acute angles, it means that they are acute in nature, less than 90 degree. So let me draw this figure first so you will understand. Draw this figure first. So from this is I given that A and B are acute angles. So let me draw a rectangle. A and B are acute angles. A, P, Q, and next I will be drawing a bigger diagram. B, M, N, angle is 90 degree. Now it is given that both are acute angles. So this is acute angle, and this is given that cos A equal to cos B, acute angles. So if you calculate from here the value of cos A, and if you calculate here from cos B, you get cos A is nothing but base by hypotenuse. So base is PA by hypotenuse is QA. From here cos B is NB. This is NB, base is NB, and this is NB. This ratio will be equal, and you know that this is QP square plus AP square equal to QA square. And next is, I'm writing some giving some space, so no, let me directly solve this. And if I divide this by QA whole square, so this will be QP by QA whole square plus AP by QA whole square equal to QA by QA whole square, which means this is will be 1. This will be 1. Now from here QP AP by QA, you can see that AP by QA is MB by NP, which so I can write it as, that is at AP, sorry, first will be QP. This is QP by QA square plus AP. Instead of this I am writing it to be MB by NB whole square equal to 1. And let him suppose this is my first equation. Now from this triangle you can see that NM square plus MB square equal to NB square, Pythagoras theorem. Now I am dividing this whole equation by by this MB square, which implies that this is NM by MB square NB, not N, this is N, NB square plus MB by NB whole square equal to 1. This is my second equation. And if you see the first equation, second equation, this MB by NB is common here and here. This one and this one is common. Yes, this is common, which implies that from these two equations, these two values will be equal. That is NM by NB equal to QP by QA. Now from this and this, which implies that here I can cumulatively write it as, like that PA by QA equal to NM by NB equal to NA, so this will be QP by QA. So if this is true, then triangle QPA is similar to triangle NMB, which implies that angle A equal to angle B. Hence proved. Now you can see that this is also done. Now seventh, if cot theta equals to 7 by 8, evaluate this and this. Cot theta equals to 7 by 8. So next question is cot theta, if cot theta equal to 7 by 8, and then to draw a diagram. So if you draw this diagram, need to take theta here. If I take theta as here, this is will be my 7k, and this side will be my 8k, because this will be based by perpendicular angle. And if you calculate this thing, this will be 7k square plus 8k square under root, which is nothing but 49 plus it is 64, 30 and 4 6 to 10 11 under root 13, so under root 113 k, 3k is theta. Now what we need to calculate is first uh, cot square theta. I'm second doing second point. This is cot square theta, nothing but this is cot theta whole square, nothing but 7 by 8 square, 49 by 8 it is 64. My second answer. Now what is my first question? It is like 1 plus sine theta into 1 minus sine theta by 1 plus cos theta, 1 plus cos theta by 1 minus cos theta. So if you calculate this is a plus b a minus b, which is 1 square minus sine square theta by this is also same thing, 1 square minus cos square theta. So this is 1 minus sine square theta, and this is 1 minus cos square theta. I don't know I don't know at this step that this is 1 minus sine square theta is cos square theta and 1 minus cos square theta is sine square theta. So if I substitute the value of sine theta, so from here if I calculate the value of sine theta is nothing but perpendicular by under root 113k, this is nothing but 8 by under root 113. And if I calculate cos theta, it's nothing but this is 7k by under root 113k, nothing but 7 by under root 113. So we substitute the value here, so this will become 1 minus sine square theta is 8 by under root 113 square by 1 minus 7 by under root 113 square. And if you solve this, you will get that nothing but cot square theta only. But and if the value will be same, and if you do this self calculations, and this you will get that nothing but 49 by 64. And if you see directly here, 1 minus sine square theta is cos square theta, and 1 minus cos square is sine square theta. If we cos theta by sine theta is cot theta, so this is cot square theta only. Ultimately, this is cos square theta only. So 7th question, this is done. I have shown you 2 ways to do this question also. Now, if 3 cot A equal to 4, check whether 1 minus tan square theta plus 1 plus tan square theta will be cos k. So this is a formula of class 11th or 12th. Yes, this is in class 11th. 1 minus tan square A by 1 plus tan square A is nothing but this is tan 2A, and cos square A minus this is 1 minus tan square A by 1 plus tan square A is nothing but this is cos 2A, and cos square A minus sin square A is also cos 2A. So you don't know this, and you don't need to check this, so I can easily check this by doing below. 3 cot A equal to 4. 3 cot A equal to 4, which implies that A is nothing. So cot A is 4 by 3. And if you draw this simple diagram, taking angle A here, B I'm supposing this to be 90 degrees, and this is C. This is 4 by 3 cot. So this base will be 4k, and this will be 3k. This is because cot A is base by perpendicular. So if you apply Pythagoras theorem, this will be 5k. This 3 square will be 9, 4 square will be 16, 9 plus 16, 25k square. If we take under root, this will be 4k. Oh, sorry, 5k. 9 square plus 16 square will be 25 k square, which if you take under root, this will be 5k. So what you need to find is 1 minus tan square a, 1 minus tan square a by 1 minus 1 plus tan square a. We need to prove that this is equal to, so, cos square a minus sin square a, cos square a minus sin square a. So this can be easily proved, but let me first easily explain to how to calculate. So this 1 minus tan square from there. So is a, and this is cot a is given to that tan a will be base by, sorry, perpendicular by base. The perpendicular by base means nothing but perpendicular for a is this. So this is 3k by 4k, nothing but 3 by 4. So if you will put the value of 3 by 4 here whole square by 1 plus 3 by 4 whole square, it's nothing but this. If you take LCM, this is 4 square minus 3 square by 4 square plus 3 square, nothing but 16 minus 9 is 7 by, this is plus, and this become 25, 7 by 25. Now if I calculate cos a, from here is cos a nothing but base by hypotenuse. Base is 4k by 5k, nothing but 4 by 5. And if I calculate the value of sin a, sin is nothing but perpendicular by hypotenuse, or perpendicular by hypotenuse. So perpendicular is 3k by 5k, nothing but 3 by 5. 3 by 5. So if you put the value of cos from here, if you put the value of, I have separately solved LHS, need to separately solve RHS. So for LHS it is 4 by 7 by 25, and if you calculate RHS, cos by this is 4 by 5 whole square minus 3 by 5 whole square. This is 16 by 25, this is minus 9 by, nothing but 16 minus, take LCM 25, 16 minus 9 is 7, which is same. This is the same, which implies that this formula holds true. Now from here, even the second method is that from here only you can see that this thing, if you write, if I had been given this question after reading whole chapter, so this 1 minus tan square, so you can write is that tan, you can write it as sine theta by cos theta whole square, and this will be 1 plus sine theta by cos theta whole square. So if you calculate, take LCM as cos square theta, so this will be cos square theta minus sine square theta by, this will be sine cos square theta plus sine square theta. So this cos square by sine square theta is nothing but 1. This is 1, this is cos square theta minus sine square theta. Hence, since a theta is, this is same. Hence proved. This was my second method. No need to use here. You just substitute the value of this here, so that should get the answer. Now in triangle ABC, right angle at B, if tan A is 1 by root 3, find the value of this. So class 9th, sorry, question 9th. So question 9 says that angle, right angle is at B. A, B, C, right angle at B, and tan A is 1 by root 3. Tan A equal to 1 by 3. So this is angle A. Tan is perpendicular by base. So if this will be 1k, this will be root 3k. So what is value of AC? AC will be given in Pythagoras theorem. This is nothing but root 3 square plus 1 square under root here and k outside, which will be, if you call this 3 plus 1 is 4, this under root 4 is 2, which implies that this will be 2k. Length of this will be 2k. Now from here, what we need to calculate is sine A cos C. So what is sine A? Sine A, sir, sine A is perpendicular by hypotenuse 1k by 2k, which is nothing but half. And what is our cos c? So cos c is, if you see this from here, cos means base by hypo, usually base by hypotenuse is 2 k is equal to 1 by 2 only. And if the sine is this, if you see cos a will also be like, cos a will be base, this is root 3 by 2. And you see that find the value of sine a, sorry, sine c, sine c will be perpendicular in the root 3 by 3 by 2. Cos a, cos c, sine a, sine c. So first is sine a into cos c. Sine a is half into cos c. Cos c is also half, plus, I'm sorry, first question, plus what is given, that it is cos a sine c. Now cos a sine c, cos a is cos a, this is sine c. Sine c is root 3 by 2 only. So if you, this is 1 by 4 plus 3 plus root 3 equal 3 by 4 equal to 4 by 4 equal to 1. 4 equal to 1. So the value answer is, for first part 9, question first part is 1. The second is cos a cos c. It is cos a cos c. So cos a is root 3 by 2. Cos c is half. This is minus sine a sine c. Sine a is half and sine c is root 3 by 2. So this is nothing but, this is root 3 by 4 minus root 3 by 4, nothing but this is 0. So the first answer is 1 and second answer is 0. This was question number 9. Now next is question number 10. So if you are moving forward to question number 10, so this question number 10 is given as, so only 11 questions are there. So in triangle PQR, right angle at Q. So in triangle right angle at Q, PQR, right angle at Q, right angle at Q. So PR plus QR equal to 25. Given that PR plus QR equal to 25 centimeters, and is also given a PQ equal to 5 centimeter. PQ equal to 5 centimeters. So this is my 5 centimeters. Now what you need to calculate? Sin P, cos P, tan P. So you need to calculate sin P, cos P and tan P. Tan is also known as tangent of P. Cos is known as cosine of P. Sine is sine of P. Sec P means secant of P. Cosec means cosecant of P. And cot means cotangent of P. This is short form. And I have explained you this. So P is in the question. So with respect to P, now PR plus QR is 25. PR is not given. Now any triangle, in any right angle triangle, now you must apply Pythagoras theorem. Applying Pythagoras theorem implies that PQ square plus QR square is nothing but P of R whole square. P of R whole square. PQ square. Now if you just write PQ is 5 square plus QR, you don't know, I think, let us take the value from here. You can write is that QR is nothing but PR, or sorry, 20, this is 25 minus PR. So I am substituting value of this as 25 minus PR whole square is equal to PR whole square. So if you expand this, is nothing but this is 25 plus 25 is 625, just 25 square is nothing but 625. Let me write this, 25 square plus PR square minus 2 into 25 is 50 PR, nothing but PR square. Now from here you can see that is PR, this PR gets cancelled, so which implies that this is 25 plus 21 plus 625 equal to 50 PR, which implies that this is plus sign, 50 PR nothing but 625 plus 25 is 650. So if you cancel this and this, so PR is nothing but 65 by 5, nothing but 5 to 5, 5 to 15, PR is equal to 30. PR is equal to 30. So this means that this is 13 centimeters. And from here, applying this, well, putting the value of PR 13 in PR plus QR equal to 26, which implies that QR equal to 25 minus PR, which implies that 25 minus this is 13, nothing but 12. So QR is 12, which implies that, sorry, PR is 13. So PR is 13. This PR is my 13 centimeters. So this QR is 12 centimeters. 12 centimeters. It's not. Now this is solved. Now you just need to find the value of sine p, cos p, tan p. So sine p is nothing but perpendicular by hypotenuse. For this perpendicular is QR by PR, with nothing but 12 by 13. 12 by 13. Now what is cos p? Cos p is nothing but base by hypotenuse. Base is 5 by 13. 5 by what is tan p? Tan p you can write sin p by cos p, or even from diagram which is given that is perpendicular by base, perpendicular is 12 by 5, so it is 12 by 5. 12 by 5. Now 11th question, 11th one word answer only. 11th is one word only. So question number 11. What it says that state whether this is true or false. Justify your answer. This is also said that you need to justify it. The value of tan A is always less than 1. Tan A, so for A equal A, so A goes from 0 to 90 degree, and tan of 0 is 0 degree, and tan of 90 degree, this tan of 0 degree is 0, tan 90 degree is not defined but infinity, not defined infinity. So this value goes from 0 to infinity. The tan A goes from 0 to infinity. Now since this is saying that this value is always less than 1, so which is implies that this is false. So once question number 1 is, or was a question number part 1 is false. Now second, part 2 is secant A is equal to 12 by 5 for some value of angle A. Is it true? It is secant A equal to 12 by 5. Now you know that secant A, for A equal to 0 degree, secant A equal to 1, and for A equal to 90 degree, the secant A is not defined or it is infinity. So this values go from 1 to infinity. Now this value is approximate, this is 5 to the 10, 25 for 20 is 2.4, which is greater than 1. It's greater than 1, which implies that definitely there is some angle A which exists. Hence this is true. This is true. Now third says a cos A is abbreviation used for cosecant of angle A. Cosecant. Is it true? No. This is cosine, not cosecant. Cosecant is different from cos. This cos A is nothing but abbreviation of cosine of A. Hence this is false. 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 Now fourth one is cot A is a product of cot A and A. No. Cot A is not equal to cot into A, because cot is something else and A is angle, and is always a trigonometric expression. So cot A never equal to cot into A, and this is also false. This is also false. Now sine theta equal to 4 by 3 for some theta. Sine theta equal for some theta. Now sine theta is equal to be 4 by 3. Now if you calculate this is 1.33. Now you know that theta goes from 0 to 90 degree, and sine theta value exists for sine 0, that is 0, and sine 90 is 1. Between 0 to 1 it exists for with values from 0 to 1, and since this sine theta value is 1.33, which is beyond this 1, which implies that sine theta for this theta value is not possible, hence the statement is false. And after doing this question, we have completed our exercise 8.1. Thank you for listening me. I'll see you in the next lecture. Thank you.